Welcome back to the hyperbolic suffering chamber. We are back once again. We are slightly short on time, but there's no better way to open than with the great words of Island Eagle. I scream, you scream, we all scream for ice cream. So it doesn't get much better than that. If you're looking for greater philosophical reflections, look no further, because this is the highest peak. So there's nowhere else to go. But we are a bit shorter on time today. So I was just doing some numbers actually, and I just realized that LeetCode adds about one problem a day. So I think last month it was like 0.9, 0.8 problem a day. They add about one problem a day. So we have to be able to solve it more than one problem a day, or at least one problem a day, just to keep up with, I don't know if I'm using this correctly, but attrition, maybe. So we're going to have to turn on the burners, okay, and blast off into the stratosphere. But we shall see what happens, because honestly, it's unknown. So today we have 55 minutos on the clockerinos, and hopefully we can get a lot done. But I don't want to rush too much, of course, because then we won't really be learning. But the goal with every session is to stay out of autopilot. So this session seems a bit shorter, but I've been up for about an hour now just reviewing Dijkstra's and stuff like that. I also realized why I think my other solution didn't work on ones and zeros, and I'm pretty sure now is because the version that I was writing, the Dijkstra's version I was using does not work with negative weight edges, or pretty much negative weight edges. So yeah, we needed a version that actually can work with negative weight edges, but we need a different variant for that. So pretty much trolled, but it is what it is. But it is time to fry. So we're just going to jump straight into it. We solved this problem yesterday without a BST, so I don't think it's worth it to waste any time on it. Surely another problem will require more depth of knowledge in I'm also we are already sorted by frequency, so they should become more palatable. So you're given a non-negative integer array nums. So you have positive only. In one operation, you must choose a positive integer x such that x is less than or equal. Choose a positive integer x such that x is less than or equal to the smallest non-zero element in nums. How can it be how can we choose a number that's less than the smallest non-zero element if it's the smallest? Subtract x from every positive element in nums. Determine the minimum number of operations to make every element in nums equal to 0. Huh? We have nums, which is non-negative. Okay. Now you have to choose a positive integer x such that x is less than or equal to the smallest non-zero element in nums. So we can choose any number, I think. They choose x equals 1. Okay. How is that? 1 is the smallest element. Okay. Non-zero. And is less than 2, which is the smallest number. Now we subtract 1 from all the numbers which are non-zero. And in the second operation, we choose 2. Okay, now nums is equal to 02002. Okay, and then we choose 2 again. Each element in nums is already 0, so no operations are needed. It feels like we need a heap for this. so we'd know what the smallest element is. But I guess we could, or otherwise we'd have to keep sorting, which kind of sucks balls. But it looks like this one's pretty straightforward. I think we choose a positive integer x such that x is less than or equal to the smallest non-zero element in nums. We choose a positive integer x. Choose a positive integer x such that x is less than or equal to the smallest non-zero element in nums. Choose a positive integer x. Subtract x from every positive element in nums. Turn the minimum number of operations. What if we'll try a ghetto version of it where we don't have access to a heap? Because we don't have access to one in TypeScript. So what if we use a ghetto version, and then from there, I think we can make sense of it. And then from there, maybe tomorrow I'll go and review on how to write a heap. In the first operation, choose x equals 1. Okay, so basically we need to know the smallest number in the array. Once we know that, we can choose a number that's less than or equal to it. So here, the smallest number is 1, so we have to choose 1, actually. Otherwise, we'd go into 0 territory. Okay, so does that make sense? Maybe I'm thinking too much path-like. Maybe you can get to a simple solution just by taking the local optima. Take away 1, and then they pretty much choose 2, and they pretty much choose 2 again. So maybe we'll just let zeros equal 0, and then what we'll do is we'll just count for constant num of nums if num equals 0, 0, and then we'll say while zeros does not equal nums.length. Now I guess you can keep track of ops and then return ops. guess we could do smallest in linear time. Let's smallest equal infinity. Then we'll just do nums dot for each. Actually, we could just do something like this. Smallest equals math. Then we'll have the smallest number. From there, I guess we'll just do what they tell us to do, choose a positive integer x, such that x is less than or equal to the smallest non-zero element. And the other thing, I guess we'll still need a block for this. We want this to run pretty much while num does not equal 0. I feel very off today. So then we'll have nums of the smallest number, but it's possible that the number could be 0. Well, it's not possible that the number could be 0, but it's possible that we come out and it's infinity. If it equals infinity, we'll just break because it means that there's no non-zero smallest number. Actually, it might be easier to allow zeros. That way we can just subtract 0 from all the numbers and it'll eventually terminate. And then we're going to subtract x from every positive element in nums. Do let I equals 0. I is less than nums dot length. If nums sub I greater than 0, then nums sub I equals nums sub I I see. So we do num sub I see. Okay. So imagine, right, if we do 1, let's just say the smallest number, with the smallest number, we do subtract 1, then we could never take all the other numbers into negatives. So we should be able to just safely subtract 1. We subtract the number without going into negatives. In one operation, you must subtract x from every positive element in nums. Return the minimum number of operations to make every element in nums equal to 0. Okay, now if we were to actually subtract it, the fact is we can choose a positive integer x such that x is less than or equal to the smallest non-zero element in nums. Return the minimum number of operations to make every element in nums equal to 0. Num sub I is equal to num sub I minus smallest. So here I'm just always taking the number that's the same size as it. So if the smallest number is 1, we're just taking 1. Could that lead to an issue? Why are they letting us use a number that is less than or equal to the smallest non-zero element? Maybe it's equal to just so we can zero out the array. If that's the case, the minimum number we could choose then, I guess, yeah, this problem could get complicated. Maybe they don't mean it that way. The smallest number we could choose to make the minimum number of operations to make every element in nums equal to 0 sounds like the shortest. Maybe why does everything sound like shortest path? But let's see if a simple approach gets us where we want to go. But it feels like the minimum number of operations can get slimy pretty quickly though. Because you would be maybe not really, because you have to remove the numbers from bottom up. You can only remove the elements starting from the smallest numbers. Otherwise, you risk going negative, which means maybe the optimal strategy is always just taking the number as it is. So maybe that is okay. So each round will be ops. This smallest is not equal. Just do that here actually. Smallest is not equal 0. Smallest is not equal 0. Ops plus equal 1. And then we'll subtract all of them. So let's try it here. We do first get the number of 0. We also have to do the number of zeros. So start here with nums. We'd get the number of zeros, which is 1. While 0 is not equal to nums.length, so 1 does not equal 5. Okay, we're going to get the smallest number by iterating through all the numbers and just taking them in. The smallest is going to be equal to 1. I think I forgot to wrap this in a num does not equal 0. Then we'll take smallest equals smallest of math.min, and the number we should end up with being 1 chosen as the smallest. Then we'll say ops plus equal 1. So we're going to iterate through the array. Right, and then we're going to say, okay, well, 1 is greater than 0, subtract 0. We're going to have 4, 0, 2, 3. I mean 4, 0, 2, 4, right? And then we'll say zeros. We actually don't want that here. Actually, no, we do want that there. Then we're going to go back to the top. We'll have 2 zeros now. I have 2 zeros now. we'll find the smallest number, which is now going to be 2. Iterate through, smallest is going to be 2. We're going to subtract 2 from all of them. And then we're going to have 2, 0, 2, 2. We're going to have 2 zeros now. Sub I. I think, look, maybe we vastly overthought that one, but yeah, it wasn't clear. I guess because you subtracted from all the numbers. So maybe that's why it didn't seem as clear, but it seemed like I should have. Whenever I see minimum or maximum, I always think something like that. That is messy, though. Ultimately, this algorithm is probably really slow. I think it would be n squared. We do linear operations to get the number of zeros. Then we do while number of zeros not equal length. For each iteration, we do n operations. We do 2 n operations. So it's like n times n times. I think this would be n squared. And we're pretty much using the data set in place. I'm pretty sure you could do this. Well, maybe you can't do it maybe you can't actually do it. Maybe you could, I don't know. Maybe you can do it in linear time, and there's a trick, like how many different numbers are there in the array? So the answer to that would be 3. I'd be curious to see if that works. New set of type number. I would just say for cons num of nums set dot add num. I think this is a property actually. But we want to ignore zeros though. Oh, wow. No way. Okay. So, okay. That's pretty good. I guess we'll take that. That would be linear time. Count unique needs. Okay. It looks like everyone probably did. Okay. That was satisfying. Maybe it wasn't a waste of time to think through it. Maximum product of 3 numbers. Given an integer array nums, find 3 numbers. Given an integer array nums, find 3 numbers whose product is maximum. Given an integer array nums, find 3 numbers. Given an integer array nums. Given an integer array nums, Find three numbers. Find three numbers whose product is maximum and return the maximum product. Hopefully we're given an array with at least three elements. We are, and the maximum number is 1,000. Could you get the maximum by just taking the top three elements? I'm pretty sure addition is it commutative? So the order doesn't matter. Looks like we just need the top three elements maybe. So maybe if we just sorted in descending order, turn num sub 0 times num 2. Or maybe that's too straightforward. Except maybe in the case of neg. Here we have it sort of in descending order. What does an array, what does a negative array look like sorted in descending order? Looks the same. I feel like if we had a longer negative array, we wouldn't get the correct answer. Just to get the correct answer. Oh, the maximum product would technically be the smallest negative number. Oh, they could be mixed. Okay, that's really clever. I guess. Oh, dang. Then you could take the two smallest negative numbers and multiply it by the largest positive number. That's a pretty cool problem, actually. Oh, it has a lot of dislikes. What if we just took 2, 3, and 4? Are there any other gotchas? Maximum product. So we could just check to see if the top three positive numbers multiplied together is greater than if negative numbers existed. Guess we could return. That would solve this case. math.max of the first two negative numbers and the last positive number, or all three of the biggest positive numbers. Minus 2. Actually, no, this could work. This is the same thing. Something feels off about this. Oh, and this is supposed to be 0. Up was -8. Okay, let's say there's all negative, all positives. This is the all positive. This is the mix, and then we need all negative. What if we say if it's all positive, it might be easier to do has positives, has negatives. Why is this so confusing? But else if has negatives and does not have positives. Well, this one is has negatives and does not have positives. I think I see what it is. If we have all positives or all negatives, then we should return the first three. So if we have negatives and no positives, or we have positives and we don't have negatives, we'd like to return that. Otherwise, I'd like to return the max of these two cases. I was looking at the wrong number. Oh man. And I was looking at the sorted outcome. Pretty much want to just change this to nums.length minus 1. I see, and I think there's another case in here. Down here, there's a mix of both, and it depends now if the absolute value of the first few numbers is greater than the absolute value of the first two numbers is greater than the absolute value of the negative numbers is greater than the absolute value of the numbers, the actual larger numbers as is. If that's the case, then we get a larger number just by multiplying the first two together. But I feel like we actually technically already solved that with this one. Length minus 1 times nums.length minus 2 nums of 0. And it matters if that is greater than there's no runtime. Maybe the servers are borked. Either way, that was torture. This solution looks like it would take linear time. Then actually, maybe we don't need this has negatives and has positive thing. couldn't we just do the max? Yeah, it looks like we just had to sort it. Guess I can't see. Actually, I guess you could. We could actually. I think n log n is slower than linear time. So I think we could just do. You could do this in linear time if we just kept stack of the largest numbers. No, but then we need the n ones to be intact as well. That's a mess. So to avoid that, we'll stop there, I think. And cubed. We not necessarily sort the given nums array to find the maximum product. Instead, we can only find the required 2 smallest and the 3 largest values. Yeah, that was any problem. Yeah, I thought we were doing this on frequency. Delete duplicate emails. Check if array is sorted and rotated. Toplets matrix. So given a string S, return the number of segments in the string. Hello. I feel like we could just count the spaces and add 1. But maybe that is ghetto. Or actually, to check if that, I wonder if we can just do string.split. You're not gonna definitely not allowed. Well, not allowed, but it doesn't really make sense to do the problem with the built-in answers, except when S is empty. All spaces count as a segment as well. So counting spaces wouldn't have worked. Looks like a segment is content. You need content space content. Maybe we can just we can do prev1. What is going on? We'll make this equal to a string, and we'll have two pretty much variables that's follow behind. So say if cur equals does not equal a space, and prev might be simpler if we just said mid and front. If end is equal, does not equal a space, mid equals a space, and front does not equal a space, then we'll do segments plus equal 1. And then after we'll say front equals mid, mid equals end equals S of I. These will all start empty. For a string like hello, they would all start empty. Then we'd say, do we have content space content? And we do. And we don't. So we'd say front equals mid, which is empty, mid equals end, which is now H, and end equals, no, mid equals end, which is nothing, and then end now equals H. That we still don't have the pattern. Then we go to E. So front equals mid, which is nothing, mid equals end, which is H, and end equals E. We still don't have what we're looking for, and then we'll have HEL. Something is definitely off here, because that should have gave us, oh, wait. Right, if end does not equal space, and mid equals a space, front, I think I have this in the wrong, wait. Wait, I'm not understanding why. Oh yeah, we have a problem reaching the last character. So if we have a problem reaching the last character, the last console log we do should have the remaining bunch. Should have the remaining bunch in it. Huh? What is the definition of a segment? It's a body of text, I guess. So if segments dot segments is equal to 0 and s looks like we just need a new model for segments. It looks like, I think I see why it has so many down votes. It feels like you kind of have to just keep changing the test case to figure out what a segment is rather than them just telling you what a segment is. Maybe that's fine though. I guess there should be a bunch of different kinds of problems. So I guess we'll redefine a segment as a chunk of text. Actually, no, we could also just change this to say if segments equals 0 and s dot length. I wonder if I wonder if a string existing counts. Oh, empty string does count as, I guess, falsy. Maybe it does not count as falsy. Because now I have no idea. Oh, and s dot length. Oh man, s dot length is greater than 0. All right, I got a dip, but that was a good session.